Hello friends, in this video we will see offset or mismatch, random mismatch in differential amplifier. Okay, so now let's consider differential amplifier. This is our differential amplifier. This is IT tail current. These two are PMOS. Now suppose if there is a mismatch between these two devices, or these two devices, say M1 M2, these two are NMOS, M3 M4, and if we consider this circuit, so this is say V in, and we are connecting this in unity gain buffer, so in this VO should equals to V in. Now say this amplifier having very high gain, but still if there is a mismatch between M1 and M2, M3 and M4, V in is not equals to VO, so there is some offset voltage between, or some delta V offset between these two inputs. So because of mismatch in devices, now let's find out this offset voltage. Now if so, this V offset delta V equals to VGS1 minus VGS2. So this because their W by L or threshold voltages are different, so both will have different VGS. Now VGS is given by VTN1 plus square root 2 ID beta. Okay, this is ID1, this is beta1. So beta I am considering half. Okay, I'm taking beta I am considering nu n Cx W by L, and ID in saturation half beta VGS minus VT square. So in saturation region we are using this equation, and with this we will find out minus VTN2 square root 2 ID2 beta 2. Okay, so this here we will write difference for this 2 is delta VTN minus VTN2, and plus, okay, so this is minus here, because here we are taking VGS minus VGS2. So if we are subtracting VTN2 minus VTN, this will be, or we will write it like this first, so that you will not get confused. So we will write 2 ID1 beta 1 minus square root 2 ID2 beta 2, and plus VTN1 minus VTN2. Okay, so this will be, now before going further, we will see ID2 equals to ID plus delta ID and id1 equals to id, and beta 2 equals to beta plus del beta, beta 1 equals to beta. So or you can say, if you are considering like this, w by l plus delta w by l. Okay, here we are choosing this beta. So now square root 2 id upon beta from here and here, minus square root 2 id plus del id beta plus del beta plus delta vtn. Okay, now 2 id beta common, 1 minus square root, you can say 1 plus del id upon id, because from here as well I am taking id common. Here if I take id common, it will come in division. From here I will take beta common, it will come in division. Now we know from this equation, if we go up from this equation, 2 id upon beta plus vt is our vgs. So this we are writing vgs here. So vgs minus vt is square root 2 id upon beta. So here we will write vgs minus vt equals to 2 id upon beta. So here we will write vgs minus vt. Okay, so this is vtn. So 1 minus, so another thing we know, 1 plus some delta power 1 by 2 equals to 1 plus delta by 2. If delta is much lesser than 1, 1 plus delta raised to power minus 1 by 2 equals to 1 minus delta by 2 if delta much lesser than 1. Okay, so this is also 1 by square root 1 by 2 means 1 by 2 power. This is minus 1 by 2 power. So this will be 1 plus delta id 2 id, 1 minus delta beta upon 2 beta. Okay, plus delta vtn. So here this small delta is delta id by id, delta beta by beta. Okay, when we solve this, multiply this, so 1 minus 1 minus del id by 2 id minus plus del beta by 2 beta minus plus del beta del id beta. So this term vgs minus vtn, so 1 will cancel. This term is very small, second order, because 2 delta we are multiplying and delta is very small, so we consider it 0. Okay, here delta vtn. Now so now this is vgs minus vt divided by 2 and del beta by beta minus del id by id, 2 we are taking common, plus delta vtn. So now this gm we can also write, this is v offset, gm we can also write as 2 ID VGS